Okay, so in ETL versus ELT, so first of all, let's see what is ETL. So ETL is, as you know, it is extract, then transform, and then load. So how this works is, so first of all, here data comes from different sources. Data comes from different sources, and types of data is also different. So when the types of data is different, at that case, what happens? For example, let's say when so here, let's say we have different nodes are there. So one data node is there, then second data node, then third data node, and then fourth data node. So first data node is in form of, let's say, CSV files are there, and then there is XML. Then second data node is, let's say, XML files are there. Then third is JSON file, and fourth is normal. The database form is there. So 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 in this case, now this entire data is being transformed into one, it is being transformed into this entire data is transformed into a one form. Okay. And then after that, at last, it is loaded into the system. So where it is, shapes. Where is that? So here data is coming from these various sources. So it is getting transformed into this one place, and then finally it is the data is being loaded finally into this database. So this is this is basically what we say is uh, finally, this becomes a data warehouse. Okay, so uh, um, our target systems hits this data warehouse. Okay. So whatever data is there, everything is first of all is transformed, extract from different sources, then stored into data warehouse, and finally the system that is using this data hits this data warehouse for any kind of um, data usage. So, for example, when I was working for the for a hotel industry, so here in hotel reservation. So uh, in hotel reservation, what we used to see from which source booking is coming, from which source booking is coming. So it may be the web inquiry, or it may be through the ping, or it may be through the scroll, or it may be through the call, or it may be through the visual visual thing. Okay, so what we were analyzing with this is who all are there to and from source which source conversion rate is better. Okay, so who all are coming from which source, and how conversion rate is better in which source. So so this entire process was done through the OLAP. OLAP was handling this. Okay, so here now here the problem was that one thing when we collect data from multiple sources. So what happens? We are not sure which data is trustable, right? Because what used to happen when people were booking this, so many times there were competitors of the hotels who were doing the fake booking, and at the end of time they were doing the cancellation of their booking in order to just make some excuses about the um, hotel. So that was one thing. Then second thing is when data is processed. When data is processed, so the um, structured structured data cost is very high, right? Because when data is processed now data when data is processed, because of that, what happens now, it will be stored in a proper tabular form, and that tabular form needs to follow a lot of database integration rules. And wherever there are database integration rules are applied, when data integration rules are applied when data integration rules are applied, the storage cost increases. Okay, and storage cost increases. Along with that, maintenance also increase. Okay, so for example, if suppose you are um, you have some data that you have kept in a library, and that data is stored with some rules and regulations. Now, after every interval, you have to ensure that the stored data is is in proper state, and it is not uh, at the place where any compliance rules are broken. You have to make sure this all time. So because of that, the data storage cost was increasing too much. And third
Can you
thing
please
was,
repeat? Can you please repeat for which the data maintenance
sorry.
cost in? Can you please repeat for which the maintenance cost increases?
See, when means one thing is that when your unstructured data is there. So in unstructured data, your data may be in let's say something is in XML form, or something is in JSON form, something is a CSV form. So that is a raw data. So you cannot do any operation with this kind of data. Okay,
Mm-hmm.
but when the same data is converted into one place, and continuously new data is coming, and immediately you are converting the new data into the structured data. So at that point of time, all the time you need to ensure that whatever data is coming and whatever data is stored is following all the compliance rules. Integration rules are up and running. At any point of time, if any of the rules are getting broken, then there can be a possibility of data loss as well. So when you structure something, like let me explain from a very basic perspective. For example, in your home, you are purchasing the rice, you are purchasing the um, flour, wheat flour, or any flour you are using, or you are purchasing any oil. So until unless you do not use this for your cooking purpose, you don't care that what's happening. You are just storing it at some box, and you are just maintaining at that place. But as soon you start cooking, so when you start cooking, now your food becomes ready to use. And at that point of time, if the food is not used immediately, or it is not consumed immediately, there are possibility of the loss of the food, because food will get rotten.
Mm-hmm.
Understood?
Mm-hmm. Yes.
Are you getting?
Yes. Yes.
So in the same way, when your data is in original form, like it is in CSV form, or it is in video form, or it is in let's say XML form or CSV form, wherever it is in original form. You don't care that what is there in that data. But as soon the data has become ready to use, at that point of time, you need to ensure that data is integrated with the solution. You need to ensure that the relationship between the data and fields are happening properly, right? If any point of time the compliance rules are not followed, there can be a question around the system. Understood?
Okay. So
So
if the
until unless
if these data, like all the data is coming in like CSV, XML, JSON, whatever you mentioned, so those data are transformed into structured form means what is it? Structured form means what type of data those are? I mean, um, is it in any particular form? Is it in any particular type?
when do you say that data is in a structured form, means it is in mostly the relational table form,
Mm-hmm.
right? But in the real world, the most of the data is not in the real table structure form. Understood?
Okay.
So when you say that the data is available, so the data can be available in form of image, it can be in form of video, it can be in form of audio, it can be in form of moon rock specification,
Mm-hmm.
right? Then the data can be in form of waves. All these are also the form of data, right?
Mm-hmm.
And
Mm-hmm.
then the CSV and XML, these are the usable forms are there, right? So it can be that there are more than 20-30 types of the data is there. So this entire data is called the unstructured data, right? And the 90% of the data in world is unstructured. Okay, right now, whatever the data you are seeing anywhere in the world, 90% of data is unstructured. Just 10% data is structured. When I say structured, it means in relational database form, from which you can interact, you can derive something, you can generate some results. Just 10% of data. Okay, but this 90% data also exists, and people are using this data to do lot of researches, right?
Mm-hmm.
Are you getting this?
Yes.
So once this entire data, this 90% data is will if in this entire data, 90% data will be covered into the structured data, there will be a huge pile of data, and the maintenance cost of this data will increase very much,
Okay.
right? So,
Okay.
because of that, it is very much challenging to process this structured data, and the cost of the data is very high. Okay, are you clear with this point?
Yes.
Okay, so here, when data maintenance increase, so because of that, the loading part, so loading where there is a storing of the becomes storing becomes costly in this storing becomes costly in the warehouse. Okay, so because of this concept, another concept was introduced, that is ELT. So ELT is just opposite. This is extract is same. Now there is, first of all, there is data. After extraction, data is loaded as it is, and then it is transformed. So now what we are doing is, whatever data you have, let's say you have a text data, or you have a streaming data, or you have the SQL data, or you have the JSON data, or you have the image data, any data that you have. Okay.
Mm-hmm.
Oh, so Alt HPA, Alt HPA, Alt HPA. Now, any data you have, what we do is, first of all, we load this entire data into a place. So place, this place is basically known as the middle loading point. Right here all the data is stored. So once data comes, this data will be stored in this as it is, wherever it is not converted, it is not placed anywhere, it is as it is stored. It no matter what format it is, no matter what thing it is doing, everything is stored in this place. And as soon something is required, this data is again transformed. So whenever it is required, this data is now transformed. And this transformation is being done from here to here. This transformation is done. Okay. So here what we have to do is here in this middle loading point, we have the data injection frameworks. There are the data injection frameworks are there, which gets data from various sources, and it injects data directly in the same form into the middle loading point. And from this middle loading point, data is extracted and transformed as per the need. So um, basically, here, what's happening is we have the data, but we don't know what to do with this data. For example, let's say there are a lot of YouTube streaming data are there. Lot of YouTube streaming data is there, or there is FB screen streams are there, or there is the text chat data is there. Okay, so at this point of time, you don't know what to do with the data. For example, if let's say you have Swiggy. Swiggy data is there. So in Swiggy data, lot of things are happening. So number like there is the reviews data. Number two, there is the photos of food. Food photos are there. Now, let's see. There is the new application is involved, or uh, um, new person is coming, or fourth data can be the delivery executive data is there. Delivery executives are there. So there are the means of what do we mean to say is that a different kind of data is just lying at say. Okay, uh, different types of data is just taking place, and we don't know what to do with this. Now, at some point, someday, some complaint comes. Now, at that, some complaint comes. Now, the data will be used. So you have all this data, you have the reviews data, you have the few food data, you have the application data, or you have the delivery executive data. Now somebody complains that there is some process with food, some problem with food. Now what they will do is they will go to a particular restaurant detail, or a delivery executive detail, and they will find out that what is the issue, and they will solve, right? In the same way, let's see, a lot of data is there from the social media. Social media is the biggest data generator is there. So this is the place where biggest data is just waving, waving like tsunami. Okay, so lot of data is there. So
Mm-hmm.
this data can be the photos, this data can be the chats, this data can be the live streaming, or this data can be the offline, or you can say recorded streaming. This data can be the social media post. Now, let's say some campaigns are coming. Campaign, campaign, campaigns are coming, and these campaigns are for the assembly elections, right? So for assembly elections, what the companies need to do is social media engineering. Have you heard of this word, social media engineering?
Mm-hmm. No.
In the worldwide, wherever the elections are happening
Okay.
nowadays, all the big parties, all in the entire world, in the America, in Europe, in the Australia, and India, everywhere there are the social media engineering performed. So this social media engineering, this analyze analyze the moods of the people at certain area, and based on that it finds the interest, and then pre- prepare prepares for the marketing. Okay, so based on that narratives are created and planted. Okay, so this social media engineering is done through the data engineering process. So all this data is there. Nobody knows what to do with the data. But whenever the assembly election comes, social media engineering is performed, and it uses all these things. What kind of photos are being included from which area? What kind of things are being published through the social media, through the social media? What kind of posts are there? In which party people are supporting? Where are the sentiments are going, how people are interacting with each other, which party is being more live in this elections. Everything is being analyzed through this. So apart from this, nobody knows what to use with this. Means people like you and me, we are not even aware of that, all the that all these kind of things are being happening, and whatever is happening we don't care. But at some point, these assembly election companies, these political parties, they are using this data for their own narrative creations. Okay, then sometimes like some case happens. So at many point at many places, people have when the crime investigation has done. So at that point of time, some people, when the criminals are investigated and criminals are tortured, so they revealed their strategy, that how he knows so much about them. So in some story that it has come that like some mother was posting the pic of when his kids going to school, and when she's picking up from there, and what kind of stuff that kid likes. So that person doesn't know anything about that kid, but from the social media, he has he got every information, that what kind of food he prefers, what kind of ice cream he prefers, what time he is going for tuition, what time he is going for let's say swimming, and any kind of activity. He know every each and every schedule of that, and based on that they planned the kidnap of a child. And when this entire thing was investigated, they knew, they came to know that how social media is being used for their engineering purpose, right?
Okay. Mm-hmm.
So these things are happening through the social media. So in this case also, all this data is live and stored at some place. But whenever it is being used, so at that point of time, people get to know that how these things are working. Okay. Understood.
Okay.
In the same way, when there are the detective agencies, are there detective agencies like you can say FBI is there or CBI is or Mossad. All these companies are also using this social media and this data means whatever you are taking, whatever you are getting from WhatsApp, from maybe Facebook or Instagram, whatever data is there, based on that, they also follow everything is this. Nowadays, many loan authorities, loan authorities also have started following this, that suppose you have taken a loan from a agency, from a company, and you are not paying off the loan, but you are um, like you are roaming around the world. You have taken the world tour, and you are purchasing the high-end items, costly, expensive items you are purchasing, and but you are not paying off the loan. So because so these are also using this data. So this data is already loaded somewhere. So what my point is telling is that every data is available now at this middle loading point. It may be anything. It may be in any form. And whenever it is required, this entire data is transformed into a structured form for whatever they require, and then it is being used further. Okay.
Okay.
Okay. So basically the um, the difference between a big data engineer and data engineer is that, first of all, if we engineer, job of a data engineer is like suppose you have different water resources are there. Okay, so let's say you have mountains, you have lakes, you have river, you have well, a lot of water resources are there. So job of a data engineer is to build the pipelines.
I don't hear you.
And then store it. And finally, if anybody now need the water, it will connect with the place where water is stored after cleaning it. Okay, so data engineer is basically responsible for designing, building, and maintaining the system that stores, process, and make it more accessible for the analyst. Okay, understood. And what big data engineer is doing is big data engineer is from whenever the means now some at some point of means on the regular basis this task is happening, like water is getting collected from various places, but now at from some point has come with the water, right? So now how that massive flood can be handled, that for that, how to build the specialized dam, how to store the data at a separate point, that point of time big data engineer comes. So engineer and big data engineer has a basic difference, that when the normal flow of data is coming on like regular days, data engineer will work. But when the big data, like Flipkart is there, and Flipkart is launching the big billion days sale. At big days sales, for example, in normal days, 5,000 orders coming every day, but in the big billion days, 50,000 item orders will be coming every day for 3 days. So at that point of time, how to handle that amount of floody situation, then you need to make it an arrangement so that now the orders can be delivered on time without any error, with maximum accuracy. So at that point of time, big data engineer roles becomes very important. So got the difference?
Yes.
I write it, or you will?
Yeah, I have taken note. Normal flow of data. When we are working with normal flow of data, data engineer will come. So if it is
Yes.
like huge amount of data handling, so the big data engineer will
Basically, big data refers to the data which is very large, very complex, and um, traditional system is not capable of handling this data effectively. At this point, what happens? There are the huge chances of getting the data lost. And because of the loss of that data, many other things, many tools, many technologies can get effective. So big data engineer specializes in tools and technologies that can process and manage the massive data in distributed systems. Okay,
come. Okay.
understood?
Yes.
Yeah, so I am not writing it over here, just maintain it on your own side.
Okay.
So this is ETL versus ELT. Okay, now next part that we are going to see is Hadoop. Okay, so till now we have discussed about data and data. Then we studied about the big data, and then we studied how to cluster this data, right? So when the huge amount of data is coming, we are dividing the data into the smaller parts, and we are sending that data, handling that data into that smaller part with the specialized dams, and controlling that floody situations at various point of time. Okay, so now let's see what is Hadoop. So in the same legacy, Hadoop is one of those technologies which helps to implement all these things. Although in the current system, what the data engineers are doing, Hadoop is not that popular now. Why? Because Hadoop was introduced into the market by Google, but later on, as the Apache and Spark has been progressed in the market, so at that point of time, what happened? The technologies that are being implemented by a Hadoop or methodologies are still relevant, but they have taken the new spaces in the market.
So Kushal, are you talking? I don't hear you. I don't hear
Um,
you. I don't hear you.
um, is it
Your voice
better
is
now?
breaking. No, your voice got breaked in between. I don't hear anything. I don't know whether you were talking or not also.
Where till where did you hear properly?
Before you write point on open source Greenboard,
Okay,
you just started. That's it.
is it clear now?
Yes.
Okay. So earlier we studied about the data, big data, and clusters. So there is a normal data, then there is a huge amount of data, and data. Then when huge amount of data is there, how we can handle this huge amount of data with smaller parts with using the clusters, and how these clusters can be processed parallelly. Okay.
Okay.
So, Hadoop is one of those technologies which helped to handle this kind of things. Although Hadoop is a little older technologies, but now also whichever technologies are being used in the background, the concept of Hadoop is only being applied, because Hadoop is the only open source framework which helped to handle the massive amount of data. Okay.
Okay.
Okay, so it is an open source framework. It is designed to handle the massive data. And third thing, very important thing is this is distributed and scalable. So distributed means the many parallel process can be run together, and at any point of time it can extend its capability without any additional infrastructure cost, right? So this is the biggest thing, because of which Hadoop became a very popular technology. So the problems before Hadoop was, number one is the data started increasing exponentially. So if you ask someone in before in the previous generation, means from my experience, what I say, when I used to study 22 years ago. So at that point of time, when there were a big there were systems in which the RAM was hardly 128 GB, and the 128 MB RAM was there, and hardly there used to be 256 GB that hard disk used to be there. So that was the capacity of the systems that point of time, right?
Mm-hmm.
And slowly, and there also, when we used to switch on the system, and this loading and booting of the system used to take a huge amount of time, like 5 to 6 minutes it was taking, and there was processing, and then system you also used to get hot, and we need to close systems because of the RAM full. But as soon the data handling the computing moved forward, more and more data was coming, and the variety of data getting started. Initially, initially data was only in form of tables, means rows and columns. But later on, when the technology increased, so everything was getting stored. It may be the video, it may be audio, it may be photo, anything, anything and everything was coming on the internet. And nowadays, in form of mobile, you can see everything is getting recorded, whether you move from one place to other place, or you browse something, or you chat something, or you watch something, everything is getting recorded. So because of that, data is started increasing exponentially, and the legacy system was not able to handle that data massively. Okay, so because of when data started exponentially increasing, so all of existing methods of storing data became irrelevant. Okay, so in at older age, there was means storing data was with the Oracle, or there was SQL server was there, or there was Sybase. All these storing data systems were there, but all these systems were contained just to store the structured data and not the non-structured data. So to handle this, to handle this, Google introduced Google developed two things. In this, number one was GFS, and number two was Google Map Reduce. Okay, so GFS, GFS was for storing the data, and Google Map Reduce was to process the data. Okay, GFS was nothing but Google file system, and Google GMR was to process the data. Understood? So by taking inspiration from this, then By taking inspiration from this, Hadoop was created. So Hadoop was created with the open source model. So GFS and Google MapReduce was being hosted by the Google, which was not very much open source. There were some restrictions were there with this, and because of that, a separate community created Hadoop separately, and Hadoop was capable of um, sharing and process the data across many low cost or legacy hardwares. Okay, so when GFS and MapReduce was there, so these two were done from the Google side, and they were having a lot of limitations. Because of that, at least GFS did not get that popularity, but MapReduce got many popularity, and with some independent network users. Means there was the developer name was, I guess, there was Dog Cutting and Umbrella. These two were there who developed this Hadoop system, and this sharing and processing of data was handled through the legacy. Means to implement the Hadoop, the people were not required very high end hardware or servers. Even on the small systems, also these this Hadoop systems could be implemented. Okay, so there were two. There were two major tasks were there um, done by Hadoop. Number one, number one was s- store the massive data, and number two was faster parallel processing. Okay, because of these two things, this happened, and the Hadoop was following the legacy systems property, and along with that, the other properties of Hadoop was number one, scalable. Sorry, it was scalable. Then there was high fault tolerance. Then third thing was it was following the network file system, distributed network file system was there. And then fourth thing, it was very cost effective. This was the main important point for getting popularity of Hadoop in the market. And this was open source. So you know what is scalability? So it was, hello, can you hear me?
Yes, I can hear you. Yeah.
Okay. Please keep on responding, otherwise it feels like nobody's there. Okay. So scalable means it was capable capable of scaling horizontally. Horizontally means um, do you do you remember what is the horizontal scaling and what is the vertical scaling? Do you remember?
Uh, what else can you-
Do you remember this?
Yes, yes. Oh,
Remember this?
yes, yes.
So what was the horizontal scaling? Okay, so it has the huge capability of scaling horizontally, means you can add as many machines as you like, right? So it can be the physical machines. Also, it can be the virtual machines, both. So you can so now with this, the number of users number of users interacting with server simultaneously. Okay,
Okay.
understood. So with the help of this, when you can scale the system, um, I'll do this in second line, otherwise you will get confused. So you can do this, and the third thing is because of this, the you can divide task as per data in more and more clusters. So as soon the data increase, you can divide the new data into more and more cluster, and and all clusters can work simultaneously without any waiting. Okay,
Okay.
understood.
Mm-hmm.
So this was the biggest thing involved with the Hadoop. Now there was the high fault tolerance, means it replicates the data across the multiple machines. It replicates data across the many multiple machines, and because of this, means now let's say there are clusters created. So at the same time, there are 1,000 clusters are created for the data, and 1,000 users are working at the same time. At any point of time, if 50 clusters also got damaged at any point of time, which was very unlikely to happen with the Hadoop, because Hadoop was very secured and very fast processed. But still, at any point of time, if even 50 clusters got not working or failed or something happens, other 950 clusters were capable of handling the load of those 50 clusters. So it helps it helps to avoid the failure of um, machines of any one or group of machines at any point. Okay,
Mm-hmm.
clear with this? Then,
Yes.
a third thing in this is that it makes sure
What is the
that
first point
uh,
in high fault tolerance?
sorry.
Uh, what is the first point says in high fault tolerance?
So high fault tolerance means at any point of time. See, a lot of clusters are working at the same time. Let's suppose 1,000 clusters are working at the same time on the same system, right? And every cluster is handling its own task of performance. Okay, at any point of time, suppose 1,000 clusters are working. Out of that, 50 have got failure.
Mm-hmm.
So the replica of those 50 clusters are already created in other 950 systems.
Okay.
Okay, so
Mm-hmm.
because of that, if any one or many number of machines get failure, what will happen? The ultimately the final output will not get hampered.
Yeah, that I got it. What is the It replicates the data across the multiple machine.
Not relegate, sorry, it is replicates.
Replicate. Okay. Replicate the data. Okay.
Okay, that was a spelling mistake. Sorry for that.
No problem.
Okay, then there is the distributed network file system. So the distributed network file system ensures that data do not move a lot, right? So before the introduction of Hadoop, what was happening for any kind of thing, data used to travel a lot from process to process, one process to other process, the other process to third process to fourth process. Like that, data used to move a lot. But when the Hadoop file system got introduced at that point of time, Hadoop ensured that data do not move because movement of data is always costly, right? So what's happening with ETL and ELT? So in ETL and ELT, data was transforming from one system to other system. Means like you have the rice, you have the flour, you have the cut, no, you have the full vegetables, and you have the oil, and you have the masalas. Everything, so means spices are there. Everything you are using, and you are making a curry out of it. Now, this curry, whether somebody is using or not, curry is already ready. Okay.
Yes.
Now, if you will not use this curry, definitely you have to put some preservative into it, or you have to store it into the freezer to ensure that this do not get older, or
Oil.
this do
Yeah.
not get rotten,
Yeah.
right? But
Mm-hmm.
this distributed file system network ensured that whatever you have, just take it and dump it over here. Okay. Just dump it over here. You do not need to worry anything. It is just stored as it is safe in the company, or in the industry, or in the factory. In the same way, it is safe in this warehouse also. Every data is collected at one place. Now, you require, whenever I want that, I want to make sandwiches. So I'll go here. I'll take bread. I'll take cheese. I'll take vegetables. I'll cut and I'll transform and make sandwich over here. Okay. So this distributed system ensured that the data do not move. Once data is there at in one system, it is already now it is stored. It should not move anywhere. Now, when you require to use something, your person will go to this data. He will do process, and it will take only that data out, and he will use. Rest data will be as it is. Okay.
Okay. Okay.
So instead of carrying the data every time to the process, the system ensured that now the process will go to data, because movement of data is costly, right? But no, because data can be like a data can be like let's say 5 GB or 10 GB data size, or 25 GB data size. Whatever the data size is there, data movement is costly. But
Okay.
but process movement is not costly, right?
What is it?
So sorry,
What is the process movement?
process means, now let's say you have table over here, and from this table, you from this table, you want to extract some information. Okay.
Mm-hmm.
From this table, you need to make a report. So one way is that you have a data in transaction table. Okay.
Mm-hmm.
Now what you have to do is you have to make a report from this transaction table. Let's say this report contains the monthly um, what to say, monthly GDP of the city. Okay. So daily transactions are happening in this table, and you want to know the monthly GDP of this city. So one way is there, get all the get all the data from for a given month to another table, then store it in a local system, then prepare a report from this data, and finally present this. Okay, so this is one way. Okay, another way is that um just Um, so for this, what one thing is required, that this transaction table is stored somewhere in the main server. Okay, from main server you got this table into the local server, and this in this local server you have done all these operations. Okay, the second thing is that number one, uh, in main table, um, create a index of the system for given month. Okay, then apply report on that and transfer the report to local system. Okay, so now what will happen? Now first of all, in this process, what's happening, you are accessing the transaction table, entire transaction table you are getting into your own local system. So let's suppose the size of this entire transaction table is 30 GB. So all 30 GB you are getting into the local system, and in this local system you are accessing the data for the month and then preparing the report. Instead of that, what you are doing, you are going directly to the system, and you are just giving an index to get the data which is required for the month, for whichever month you are looking for. So overall size of table is, let's say, 30 GB. Now here, when you are accessing the data for the month, you are getting maybe it may be just the size of maybe 1 GB only, or maybe not even 1 GB. Now you are applying the report on just that 1 GB data only. Okay, so one thing, transfer of 30 GB from one place to another place you avoided, and instead of that you are just hardly using 1 GB over here, and from that 1 GB only you are creating this report. Okay, so that report size may be not even 100 MB, and that 100 MB you are transferring from server to your own local system. Understood. So
Okay.
instead of transferring 30 GB from one system to other system, what you are doing, just applying the report or your query directly with the indexing for the given month only, and you are only transferring 100 MB of report into local system. So did you reduce the transferring of the data?
Yes. Yes.
So do you remember the concept of move computation we discussed over here? Move computation. Understood.
Yes.
So this is the concept of move computation as well. So in distributed network file system, it Hadoop makes sure that data do not move a lot. Rather, here in case of instead of 30 GB, we are only moving 100 GB from 100 MB from main system to local system. Okay, so here what we are doing is we process the data wherever it is stored. Okay,
Mm-hmm.
so
Okay.
this distributed file system follows the concept of move computation in the cloud. Okay,
Okay.
understood. Then this
Yes.
is very cost effective because it comes under the Apache formation. So Apache formation is completely out open source system. So it is free to use and modify. It is very much free to use and modify, and because of that, um, and very important part, third part is that it maintains maintains data locally as well, because it don't require it don't require high configurations. Okay, so remember here this point: sharing and processing the data across many low cost or legacy hardwares. Okay, so you do not require very much high end hardwares to implement the Hadoop system. Because of that, it becomes very much cost effective. Okay.
Okay.
Then for this concept comes under this um, open source. Okay.
Okay.
Any doubt in?
No.
Okay. So now next we'll discuss the Hadoop ecosystem. So there are few points, few things are there under the Hadoop. So there are few Hadoop ecosystem terminologies are there. We'll discuss that. Hadoop ecosystem. In Hadoop ecosystem, what happens is the collection of open source projects and tools that work together. Okay, so Hadoop is basically the collection of open source projects and the tools which works together. So there are few main um, things are there. And out of that, number one is HDFS. HDFS. So this HDFS, do you know the full form of this?
Hmm. No, I don't
So this,
remember.
sorry.
I don't remember.
So this is Hadoop distributed file system. Okay, so do you remember there was uh, when when we were um, using this window and all, so what file system that system follows?
I don't get your question. Repeat.
Suppose you have a Windows system is there. So in Windows system, C drive, D drive, you have, right? So in that C drive and D drive, usually what file system has been followed?
What file system?
Do you have you ever done the installation of Windows in your system?
Yes. Yes, I did.
Okay, so while installation, it asks that what kind of file system do you want to follow? Have you selected at any time, or did you notice that what is there?
It's,
Have you heard of FAT32?
yes, I have heard, but I usually follow the video when I install it. So yeah.
So there are two file systems are there, FAT32 and NTFS. These two systems are there. usually when you install the Windows. Apart from that, when install the Linux, so there are main partitions is slash um, there is slash etc partition and slash system. What's happening? This slash why slash system. These two main partitions are there, which follow. So these two are used for the Windows, and these two are used usually for the Linux installation, right? So Hadoop distributed file systems is capable of handling all these file systems together alone. Means these two are for the Windows and these two are for the Linux, and Hadoop follows the combination of all these things alone. So because of that, Hadoop uh, can store and support the data from variety of file systems at the same time. Okay,
Okay.
so and, since Hadoop is since Hadoop is a distributed file system, so if suppose you have 100 nodes, so at the same time it can work on 100 machines as well. As many nodes and that many machine it can follow at the same time. Okay, so this is the first thing in the Hadoop ecosystem. Second thing is map reduce. Okay, so what is this MapReduce? So MapReduce is basically it is inspired by GMR. GMR is Google Map Reduce. It is inspired by the Google Map Reduce. So basically, this helps in processing the large data splitting, large data splitting into very smaller parts. Okay. As you heard of that, with the distributed file system, it do not process the one data from one system. It process the same data through various systems. Okay. And
Mhm.
when this splits into the smaller parts, these smaller parts can run parallelly. Okay.
Okay.
So basically, when we talk about the HDFS, so HDFS is mainly for storage of the data, and MapReduce is for the processing of data. Okay,
Mm-hmm. Okay.
understood.
Okay. Yes.
You might be feeling somewhat boring because lot of concepts and lot of theory is there.
Yes, there are
Okay, but
so much concepts, and it seems like everything is important. So either I have to understand very clearly, or I have to memorize the terms so that I can.
no, you don't need to memorize. Slowly means this theoretical part will take one or two more classes. After that, this all concepts will be coming into the implementation. Then you will remember everything.
That is what I thought in the beginning, but it seems like it's there are so many concepts. So yeah,
That I told in beginning also. There will be many theoretical things will be there now.
okay, that's fine. That's good also, so that I can
But
understand right
when
away.
if you know all these basic things and terminologies and all, then
Yeah, it will
you
be
can
easy
start
for
at
me when
least.
I'm. Yeah, 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 yeah. I understand when we are doing the
Mhm.
real. I mean, the technical part. It will be more helpful.
Yes, yes, that's what in the beginning also I told that lot of concepts will be there. So you have to be a little patient. Just one or two more classes. After that, this implementation part will come.
Okay,
Okay.
okay,
The
fine.
third thing is yarn. Yarn is again. So I have a separate notes also. Means this no, these are the class notes that I'm creating. Apart from that, I have separate notes as well. I'll provide you those notes after these 2 3 sessions, so you can just mug up those and you will understand what is that.
Okay, fine.
Okay. So
Okay.
this is another yet another resource negotiator. Negotiator. Okay. So what happens, like, let's suppose this is HDFS. Okay. So HDFS, it is storing your data. And here it is, let's say this is MapReduce. Okay. This is processing the data. But here somewhere in between, there is yarn. Okay. So
Mhm.
what yarn is doing is, let's say a map reduced is engaging the resources. Okay. And once one means, let's suppose there are 100 resources are there, and out of that 100 resources, there are 80 resources are engaged by map reduce. So yarn ensures that as soon any of this resources gets free, and if any other requests are coming from any sources, yarn ensures that from that other request those resources are available as soon they are free from this map reduce. Okay, because on this HDFS, lot of requests might be coming. So at the same time, one request has come, then second request has come, then third request has come. So this requests are being processed via this map reduce. Okay. So yarn ensures, yarn basically it coordinates with this system. It coordinates with this system, and it ensures that as soon any information or any data part is free, how to make that resource re-available for other process. Okay. So the task of yarn is, it decouples it decouples the resource management for execution of the application flow. Okay.
Okay.
Understood. So it decouples the resource. So in this way, um, the means, as the resources resources are engaged by the map reduce, yarn keeps an eye of engaged resources resources, and as soon the resource use gets over, yarn makes sure that it is available for the next process. Okay,
Okay.
understood. Any doubt?
So what is decouple?
So decouple means, suppose one task has come. Okay, now
Mhm.
that task is means, MapReduce has engaged, like, suppose you have the availability of 1,000 resources. Okay, a
Mhm.
map reduces has engaged 500 resources out of those 1,000 resources for first task. In the meantime, in few seconds, second task has come, and that task requires, let's say, 600 resources. Now 500 are already resources. For 500 resources are already engaged by MapReduce at the first time. So what Yarn will do? Yarn will manage at the beginning somehow with the 500 resources only. But as soon from the other 500, As soon as other resources starts getting free, it immediately makes those resource available for the second request. Okay.
Okay.
So
Mm-hmm.
tasks which are engaged with the map reduced, as soon the task is over, yarn ensures that those resources are free from that process now.
Okay.
Okay, so there may be a instance that like 500 resources are engaged by task one. So there can be some resources which may get free earlier. There can be some resources which may take the longer. So as soon the task or resources starts becoming free, it detaches them from the process or from the task. Earlier, what used to happen, suppose there are like 500 tasks are engaged for the first process. Until the first process are is not complete, not complete, no resource gets free, means all resources are engaged.
Okay.
Okay, so yarn has introduced to make sure that your resource is available for other process. Okay.
Okay.
Mm, in in real life, if you would see, like in our home functions, when people used to take food at in the line. Okay, so somebody is distributing the curry, somebody is distributing the chutney, somebody is distributing the curd, and means lot of items are there. Okay, so like there are 10 items are there, and 10 people are distributing all those 10 items. Okay,
Mm-hmm.
now at some point of time, somebody told that a new item has come and that also needs to be distributed. Okay, so like one person who is distributing the chutney at all the places, as soon he finishes the chutney and now chutney is available with everyone, he will leave the chutney and he will start distributing that new item. Okay,
Okay. Yeah.
so so that is the decoupling of the task.
Okay. Just a minute, Kushal, 1 minute.
Yes, yes.
Yeah, please.
Okay.
Mm-hmm.
Now, next is very popular term, that is Hive. Do you heard of Hive?
Five? Five. Oh,
Yeah.
I cared of, but I don't know what is that.
So Hive is basically a query engine, but it's not the database. Okay. This is not the database. This is just a query engine. So, uh, like first of all data is there in machines and MapReduce used to work and process this data. Okay, so like MapReduce is written in Java. Okay, MapReduce was written in Java, and basically many people, because of the complicacy involved with the Java, many people were not comfortable to use this Java very frequently. So people wanted so instead of instead of Java, people wanted some query language like SQL, because Java has so many technicalities are there, and uh, la-
Yes, it's a bit complex language. Yeah.
Okay, so Java is very much complex, and many people wanted to get rid of this Java kind of things, and they want some query language. But also at the same time, they wanted the performance of same as MapReduce. Okay, because MapReduce performance was very fast and very much distributed. So because of that, they wanted the same performance, but not from the Java. So basically, the Hive abstracts the MapReduce in backend and um, translate the process into the SQL for MR jobs. Okay.
XML. Mm-hmm.
So, because the Java was critical and a lot of issues were there and critical, it was very much complex. So, because of that, the Hive with the Hive they got a middleware where they can do the same level of processing with the better level of engagement. Okay, and then the next part was Scoop. So this scoop is basically a facility of import and export between Hadoop and relational database. Because when Hadoop was introduced, there was a lot of things were there into the form of relational database. Okay, so in the relational database, there were many constraints constraints were involved, and there were many integrations factors were involved, and apart from that there were lot of rule based data also created. But with the HDFS file system, since data was in different formats, so all these things were not very much friendly for the Hadoop. So Scoop created a import and export system between to create this relationship, so that the relational database can be used along with this. So all these systems now were the part of Hadoop, and they created a very much good infrastructure for the for understanding of the this cloud-based network process. Okay, so is this part clear?
Yes.
Okay, so next is HDFS. We'll see this HDFS in a little detail, and then we'll see MapReduce in a little detail from tomorrow, so and what all terminologies and what all things are there. So it will take maybe one or two more classes for me to get this thing done. After that, uh, we'll do the implementation, and we'll see how these things are being implemented. We'll keep it at
Okay, so next two classes means this week you'll be taking one class and then one more class
tomorrow.
next. Yeah, tomorrow you will be taking one,
Yes,
right?
tomorrow I'll take. Yes,
And then next
and
week you will